So my topic for today's discussion is spatial careers in engineering and technology. And in this talk, we will be talking about technology, we will be talking about data procurement and data analytics, and we will be talking about delivered products with respect to various applications. These applications are very social applications, and the discussion will be also on careers with respect to civil engineering, with respect to data science, IoT, and big data, and of course, careers requiring machine learning and artificial intelligence. So this is a very recent picture. You see, NASA's Webb delivers deepest image of the universe yet. So this is one picture where lots and lots of data have been collected by a single instrument, and then they have been, collected and processed, and then there is a single image which has been created. This is the wonder of mankind's scientific development in the world of astronomy. From the galaxies, let us come to the solar system. And from the solar system, let us talk about the Earth. So there is a big conspiracy whether the Earth is flat or whether the Earth is round. We strongly believe that the Earth is actually round. And of course, the Earth is being monitored by satellites. So the basic problem why we are talking about this spatial career here is because in our junior classes we have studied the 3D space problem. You know, the Cartesian coordinate system which was formulated by René Descartes. And the 3D space problem becomes in the case of the Earth, because the Earth is spherical, it becomes a spherical coordinate system. But unfortunately, the Earth's surface is not very mathematical. As you can see on the right end of the screen, it's a colored image that you are seeing. The distribution of magnetic materials in the Earth's surface, they do not allow the Earth to be of a very mathematical nature. And therefore, measurement of heights with respect to the Earth's surface becomes a big problem. And therefore, we have to understand the shape and size of the Earth and the phenomena which are occurring on it through measurement and recording devices and processing and analytics. So let us talk about Earth observation. So there are various stages of Earth observation. We can talk about satellite-based surveying. So there are satellites mounted on the atmosphere, and then there is aerial surveying. So there is an aeroplane carrying a camera. There is unmanned aerial vehicle surveying, which is an emergent area right now. And there's a lot of careers and not many careers here in the area of unmanned aerial vehicle surveying. And then, of course, there is a terrestrial surveying. Why this? Why these four stages are there? And from the satellites, you can do some things. From aerial, you can do some things. Like, for example, if you want to cover a large area in short span of time, aerial surveying is the best thing to go. But if you want to cover a small area but with a larger amount of detail, you are going to do UAV surveying. And then if you want to increase the detail still more, then this is called terrestrial surveying. So in terrestrial surveying, this typical amount of terrestrial surveying mostly is done by the civil engineering people. Of course, not an emerging actually, there's a very modern method of surveying is the surveying by GNSS, Global Navigation and Satellite Surveying, which in general, or rather the older term is the GPS. So the GPS is the system which was developed by the Department of Defense, and then Europe came up with Galileo, then India has come up with Gagan, China has come up with Baidu, and so on and so forth. So there are very many global navigation systems which will help you navigate through the city through a particular period of time. So if I talk about remote sensing, the satellite-based surveying, you have talked about remote sensing. The remote sensing happens in bands, and there are some specific bands in which remote sensing can happen. In other bands, remote sensing can't happen because the atmosphere neither lets these wavelengths escape nor lets these wavelengths enter. So the atmosphere is a natural blocking to all these wavelengths. So therefore, it allows the microwave wavelengths and it allows the infrared wavelengths. What is the benefit? We will come to know later. So one of the careers that is there for electronics based engineers or basically who are working in sensor technology, that is sensor design. So, and then, so if you are able to design the sensors, you will be able to store the information from the sensors into a CCD, that's called a charge coupled device. Most of the satellites and your cameras, your hyperspectral cameras, or any camera, your mobile camera, they contain these CCDs. The size of the CCD varies from place to place. Like, for example, if you are working for uh, the Landsat satellites, so if you are working for space satellites, the CCDs will be larger. I would request the participants to keep their mind.
बोल रहा मेरे को तो 4 बजे
So there is a particular brand of study. So if you go back to this particular uh, image, you can see that there is this particular band. We call it the wavelength range. So there is a minimum wavelength and the maximum wavelength. And in this wavelength range, we can divide this wavelength range into multiple smaller wavelength bands, wavelength ranges. So, and then therefore, since we can do that, we can develop what we call as a hyperspectral camera. Of course, the photogrammetric camera is a high resolution camera. ये जो, and these days you are talking about 24 megapixel camera or 50 megapixel camera. So these are very highly precise camera lens arrangements, and so these are fixed focus cameras, and these are used for photogrammetry. We will talk about what photogrammetry is later. But you can also build hyperspectral cameras. That means these cameras can divide your entire wavelength into smaller bands, and therefore you will be able to find out which species is there on the ground. So suppose, for example, your vegetation is having some stress. That means if the weed has infected it, or there is an insect which has eaten the plants or not, if the plant is diseased or not, you will be able to detect these things with the hyperspectral camera. So this is a camera which will be helpful for the farmers. Imagine mounting this camera into a drone, and you will be able to tell the farmer, look, your crop is being infected by weeds or insects. You have to take care of the crop. Just imagine this, that you can do that. So as I told you that there are 4 GNSS constellations. Well-known GNSS constellations are GPS, Galileo, GLONASS. GLONASS is the Russian one. The Baidu is the Chinese one. Various constellations are now emerging, and of course, Indians are not behind. India has come up with this Indian Regional Navigation Satellite System, which works only in India. They are not a global one, but they work only in India. But the two of the technologies which are there is Gagan and Navi. And let me tell you that I recently attended one meeting, and in that meeting, people were asking for proposals for design of the receivers. So that means a guy who is interested in entrepreneurship can actually create a startup, can actually create the device and sell that device in the market, and people will be ready to buy. And the third device, which will be accepting signals, Galileo, GLONASS, Baidu, as well as using the signals from Gagan and Navi. Just imagine you have a lot of market potential here. So to do that, suppose for example, if I were to do this, what would I need? I would need to understand what amount of information do the signals contain. So that will need a bit of signal processing. And if I know how to do signal processing, which is a part of information technology, signal processing is there information technology as well as in electronics engineering. If I know how to do signal processing, I will be able to use the GPS and create my own product. So there are some major questions that we'd like to ask. The one of the questions that I would like to ask is where to put high voltage power lines. Why am I asking this question? Because high voltage power lines can create fires in very serious summers and all, because they have thermal signatures. So where to put high voltage power lines? So we cannot give that answer that, oh, don't put high voltage power lines. That is not going to be a solution. We need these power lines, because if I want to empower the people of India, most of the people are in the rural areas, and therefore we need high voltage power lines. So we cannot answer, don't put the power lines. Okay, so can we tell the farmer which crops to plant in any season, which crops to plant? So there are two seasons usually, and which crops to plant? What technologies can I use? All right. Can we help develop a corridor to connect various heritage sites? Now, in India, there are several heritage sites, unlike in other countries. But in India, there are several heritage sites. Can we connect them by a corridor? So, what will happen if I connect them by a corridor? I will be able to actually develop the business of those particular places. I will be able to encourage the artisans of those particular places. And of course, I will be able to improve the economy of the country in general. Can I do that? Yes, I can. How do I help to build a road on a mountainous region? How do I decide what will be the what will be the locations where I take the turn and all that? Yes. So this is one question which is being asked. People have just made the roads there because they have made the road just like that. There are a lot of accidents due to landslides and all that. Can I help a new person in the city to choose a place of stay? Now, with the emergence of a lot of GPS or GIS based technologies, the question is, should the new driver go up on the flyover or below it? Suppose, for example, there is a new driver enters into, suppose somebody who is living in Pune enters Aurangabad. Suppose somebody who is living in Aurangabad enters Guwahati, for example. And I believe there are people from Guwahati, Dishpur in the particular audience. Suppose somebody outside the city enters into your area, and then he is lost in the city. Should I go up the flyover or below the flyover? Otherwise, I will get lost. So, there, what kind of arrangements do I have? All right. Then, can I schedule waste collection and dumping locations? This is the question. Then, can I set up mobile company? Now, the mobile companies are having a real problem now. Why? Because if you are in Aurangabad, this is a typical observation in Aurangabad. If you actually are in Aurangabad, you may not receive 4G quality signals at all places. It is happening. That means the mobile companies have set up their towers at the wrong places. So, can I help the mobile company set up these routers? Yes, maybe yes. Can I help people in better management of criminal incidents? Maybe yes. This is one of the careers there. And I mean, you can go to the police actually. I mean, police employment. So then decide renewable energy generator locations. Can I do that? Can I monitor losses of vegetation to protect biodiversity? This is one of the projects that can be done. Can I locate forest towers? And can I find places to have flood resilient infrastructure? Now you see what happened in Uttarakhand long back in 2013. You see, there was a flash flood, and because of the flash flood, there was flood in Uttarakhand, and then in the next consequent day, there was flood in Allahabad. So that means, and people, there was a large damage to infrastructure that you can see here. What can I do? Can I rescue people who are trapped in a flood? Assam has been witness to the recent flood. In the past few years, Kolhapur, I remember, was also witness to a flood, big flood. People were trapped. I don't know how people were escaped, rescued. And then how can citizens avoid getting affected by noise pollution? Because in behind every truck that you see on the road, you will see horn, okay, please, or rather horn, please, okay. That is how it is. But horn, okay, please. That is what you see, and all the people, all the vehicles that you have on the road, they are playing their horns because it appears that it's a famous pastime. And can I help the wildlife? Okay, and then can the government monitor and control contagion? So I will be answering some of these questions, and I will be leaving some of the questions unanswered for you to explore in the future. Now, if I were to segment all these career prospects, you can see there is a career prospect in data procurement. So you can procure GPS data and sell it. You can you can process the data. Like for example, images are being captured by satellites and data is being captured by drones and planes and all that. So you can do the processing of the data. Then you can analyze the data and give some knowledge out of it. Then you can disseminate the data. That means you can distribute the data. So much of the data distribution has government control right now. But what you can do is you can create products out of this data and then disseminate it. So there is one data dissemination opportunity. And of course, there are application opportunities. A lot of the government and private organizations are working on these applications, the social applications. So this segmentation, I mean, if you are talking about spatial careers, this is how the segmentation of the career is. Okay, let us go forward. So one of the biggest organizations in India, which was the foremost government organization, even before independence, this is the Survey of India. Most responsible for most of the map preparations at 1 is to 50,000 scale, 1 is to 25,000 scale up to some extent, and to for certain cities some larger scales. Now, this organization employs people who can do surveying, who can do mapping, who can do GIS, and who can do data analysis, georeferencing, all that kind of jobs. This organization employs them. And of course, there is a corporate organization of ISRO, which is called Antrix Corporation, and this is the organization come with complete government funding and complete government participation, and it's a corporate wing of ISRO, Antrix Corporation. So let us start with uh, the career opportunities. So if you are talking about surveying, so usually people will do surveying in empty barren lands for pressure construction or building up roads or building up dams and all that. So government PWD, Survey of India and chartered surveys. This is one of the areas where you can work in. Then again, there is a GPS-based survey. You can see this is what you are seeing on the screen right now is a GPS. It's a land surveying equipment, and you can actually do a lot of surveys and also cater to disaster management. We'll see what disaster management thing is being talked about. So then there is tunnel surveying. So when you are designing a tunnel, when you are digging a tunnel, you need to keep on surveying. Whatever the equipment that you are seeing here right now is called a terrestrial laser scanner. And the terrestrial laser scanner can throw more than 50,000 beams per second, and it can collect that many returns from that particular on that particular instrument, store it on a USB stick, and then a guy with a very highly powered computer with a GPU, a graphical processing unit. This is called a GPU. NVIDIA ka naam, you might have heard the name of NVIDIA. And you can cater to the tunnel survey. Then there is this is an image from Sydney, Australia, and you can see the detailing with which the city has been imaged. The image of the city has been captured. You can see the runways and all that. And these images, recently, why these are important? The Airport Authority of India observed that in long back when Chennai was having a flood, a lot of the Chennai International Airport was flooded. Why was it flooded? So that understanding is required by the Airport Authority of India. So I'm sorry for the wrong spelling of Airport Authority. This information is required by the Airport Authority of India and the disaster management cells. So because of that flood, a lot of the flights could not take off from that airport. So again, here further detailed images are available, more detailed images are available. So if you are talking about applications to agriculture and town planning, you can see, you can image and you can see that this particular image has features in a very different color. And why this different color? This different color is known as the false color composite. The false color composite was used and is still being used by remote sensing scientists to understand the nature and development of vegetation. All the all the features that you are seeing in red basically denotes agriculture. All those features which you are seeing in light blue or light cyan peacock blue color, okay, my perception of color is that this is cyan color, and this color, anything which appears is urban area. So there is some urban area, there is a water body which you are seeing, because of the shape you can recognize, and there are areas which may be either forest or agriculture. So mostly this is expected to be agriculture, and this particular understanding is required to understand to comprehend the growth of a city or the sprawl of a city. We will see examples later. And you can see from these remote sensing images, we have been able to create these diverse kind of images. Of course, this is downloaded from the internet. This is not my image. Uh, but you can see that various cropping patterns exist in nature. If you see the, this image that you are, I mean, where my mouse cursor is, if you see this image has rounded cropping patterns. Now you might wonder who crops up, who plants the crops this way, rounded manner. But this has happened because they use a particular sprinkler which moves in a rounded fashion. This is the reason why the crop is like that. Okay, so and then because of the mechanism of irrigation, you have a different growth of the crop. So this is called a cropping pattern. So from the cropping pattern, you can understand what can you give the knowledge to the government. This guy is using sprinkler, and so because this guy is using the sprinkler, he is using this much of water, and so if this is the water if he is using, then this much of charge should be given. Now in India we have the agricultural law that for farmers there is a certain subsidy, but the water that is to be supplied, that is not infinite. So if there is some billing to be required, you can say ki bhai, this farmer is using this kind of water, so there is this kind of insurance policy that has to be applied. So there are now various interesting approaches are called the precision agriculture. What is precision agriculture? The soil, now why this precision agriculture is required? First of all, you understand this. The soil is a heterogeneous medium. That means even if you draw a 10 meter by 10 meter square on the soil, on the ground, if you draw, the property on one end of the square will be different from another end of the square. That means it is not a homogeneous medium. And because it is heterogeneous, you will need to know by use of sensors, by use of IoT, or by use of any other big data mechanism or data procurement mechanism, where to put what fertilizer, where to put what pesticide. And therefore this practice is has been emerging. It was emerging a long time back in the West, and it has also now come to India. And this is what we call as the precision agriculture mechanism. So this is photogrammetry. Now photogrammetry, what you can do? What is photogrammetry? Basically, you have two eyes. Remember, in your life, you have two eyes. So with the two eyes, you have what we call as a depth perception. And same way, if I have two different cameras from two different angles and I take two different images, I will be able to get depth perception. So if I get if I say depth perception with the help of some mathematical model, I can retrieve the 3D model of the object that I'm imaging. So that means if I go to a heritage site, that means if I say, if for example, if I go to Ajanta, if I go to Daulatabad Caves, Daulatabad Fort, okay, in these areas, if I fly a drone with a camera and I take the image of the fort from different angles, I will be able to capture the image of the fort and I will be able to capture the 3D model. It can happen based because of the 3D photogrammetry. And this is what we call as the airborne LIDAR survey. So you can see there is a plane equipped with a laser sensor, and the laser sensor is actually throwing a beam down to the ground. And what is happening is the plane is throwing the laser beam. The plane, therefore, the sensor, the laser sensor which is mounted on the plane, it will measure the distance and calculate the coordinate. This is what it does. And see, the GIF which you are seeing here, it's a very simple one, but essentially it is throwing 50,000 or more than 50,000 beams per second. And in a very short span of time, you will be able to image most of the city, most of the town. If I want to capture a city like Guwahati, or if I want to capture a city like Aurangabad, which is a very small one, I will be able to do in a very short span of time using airborne LiDAR survey. And to process that data, and to integrate that data with the terrestrial data, because from the if I image from the top, I might be able to get the height of the building, but if I want to integrate that data with the facade, what they call it, the facade of the building, if I want to do that, then I have to resort to terrestrial laser surveys. Again, the terrestrial TLS survey can capture very huge amount of data in a short span of time, and you will need a system with GPU to integrate uh, a topside data, that means airborne laser data and a terrestrial LiDAR data, and create a product out of it. Okay, so just we will show you certain products in a few moments. So let us see this. Let us see how this goes. So we have this transport ministry, and you can use the digital elevation model and the obtained from these lidar data or synthetic aperture radar data. And synthetic aperture radar data is available for free. Free available free hai. You just open an account, you can download the data and create the 3D model of any area which you want. Okay, this data, this satellite is very active, and it is capturing the data once every month, at least once every month as per my observation. So it is capturing the data once every month, and you can actually create the 3D model of any particular town and monitor. If I want a scenario in terms of big data, and I can monitor how the city is changing, okay, in 3D, how it is changing. So like for example, this is a mining example. So if there is a mining site, and if I go there, they are digging the mine, they are digging up the area, and because this is a copper mine, so how much of the sand or how much of the ground earth has been dug out, I can calculate. If I use surveying, again, let us see this. I can prepare cadastral map. Now you see what has happened in India. If you leave out some planned cities like Siliguri or Chandigarh, well planned cities, or Magarpatta in Pune, if you leave out these particular areas, a lot of the cities, they do not have these cadastral maps, and there is a huge opportunities for surveyors to collect these cadastral maps. So this is one area where the town planning department can require your help to do that. So the railway ministry, of course, the railways have this problem of, regular problem is there. It is a regular problem. And on the railway track, there is some or the other distortion. Somebody is creating nuisance, mischief. Somebody is, or some tree is falling down on the railway track. So if I want to automatically, create an automated system, an artificially intelligence enabled system, so that a train can be stopped before it you know it it gets it gets into some collision with something lying on the track, then it will be great for saving a lot of lives. So essentially, this is an automated recognition example. So this is an AI ML example, okay, where you can use survey data or LIDAR data, mount it on the LIDAR sensor and mount it on the train and enable the train to stop automatically when there is a darkness. Like for example, the driver cannot see the very well on the track, and then there is some obstruction, and in time he can stop the train. To prevent any major accidents. So this is how the data would look like, okay, to the driver. Then this is one of the interesting part is the traffic, traffic based monitoring. And you see what has happened is if you go to a lot of the areas in France, they have these city maps. And if you want to go from one place to the other, they have scheduling. How do I decide which places to connect by a bus, which bus routes to develop? This is an artificial intelligence and machine learning example. So you integrate traffic data, also you place sensors all over the city, you get the number of buses flying or the number of vehicles there on the side, and then based on that you realize and propose to the city that this is the route that you require. Or for example, let us suppose that you have traffic signals and you want to time the traffic signal such that there is minimum amount of traffic jam in at any point. Because what has happened is there is a study that the average citizen of Delhi spends 11 days, if you just total up the waiting time, 11 days in a year waiting at a traffic jam. So there is a study like that. And so therefore if I want to minimize that kind of study or minimize that kind of weight, so this is the kind of example that you need to work on. So this is an AI ML example. So you can see using LiDAR scanner also you can this is monitoring, visualization, machine learning, identify which artifact is what. Then let us see talk about security and visualization and machine learning. This is another example how the LiDAR data looks like, and this visualization has been created out of LiDAR data. And look here. So this is a forestry example where there is a lot of foliage, and where the LiDAR data you will require this in order to understand how many trees are there. But this is a machine learning requirement. Why? Because the forestry department wants the inventory of trees. How many trees are there? What kinds of trees are there? So if you developed a database like, okay, this is the people tree, this is the sal tree, this is the ashoka tree, and this is that tree, this tree. So you create a database of all kinds of shapes and sizes of trees, and then with the help of that database you train your algorithm, and you will be able to use machine learning and visualization for this kind of video generation. You can also see an example of electricity. That's like, for example, I told you about the electricity problem, and you see what is happening here. The high voltage lines can create a forest fire. And because those high voltage lines can create forest fire, you need to recommend to the government. And so therefore you use AI, ML and big data, because that kind of data which is needed here, that kind of density of the data which is required here, it is 26 points per meter square. This is the highest density as on date. 26 points per meter square. When it comes to the area of survey, the size of the data is like 26 GB, 30 GB. I'm saying in the minimal terms, but that is the size of the data. So this is the big size data, not big data per se, but you need to apply your machine learning and machine intelligence on that size of the data and recommend to the government, look, you have to cut your forest such that it stays away from the electric lines. And this is a sustainable job because the forest will keep on growing and your infrastructure will keep on increasing. And so therefore this is a sustainable career here. And of course your requirement of urban infrastructure, your requirement of cities and requirement of residential areas, requirement of companies to work. And this is how the scene is being changing, scene is changing from California, and this is a prediction how the scene will change. And similar prediction is here, you see. This is a visualization which has been created from Google Earth images. And this is, if I can make a model out of it, I can use data science and prediction models, and I can predict how things will look like in 2050, how things will look like in 2100. And I have to plan based on what the future is. Otherwise, our future will be in jeopardy. So as a result, we can also see this particular understanding is pretty much important. See how the sprawl is going on, and you see there is a lot many images to be processed, and these images of very huge size. And let me tell you that if we download one image today, that image one scene from Landsat or Sentinel or these websites, these are free images. If I download those images, what will happen is those images are at least 800 MB. The collection of the entire collection is 800 MB. I have to process that collection and create this animation. So I cannot do it manually. Remember, if I have to do this particular simulation, I cannot do that manually. I have to use AI, ML, and big data analytics. I have to use data science. There is no way in which we can do it manually, because manually will be donkey work. We were talking about sound. So this is one map which has been created. How can we do this creation? We can put sensors. We can use IoT here. You see, we can put sensors at various places in the city and record the intensity of the sound. Okay, once we have recorded the intensity of the sound, and then we can create this map. If we can create this map, what will happen? I can then recommend to the city people that you have to create sound barriers. And look, this is what is happening here. This is a 3D simulation model of how the sound is changing in a landscape, and this is helpful for creating or recommending to the city municipal corporation of how we can create sound barriers. Again, you see, unfortunately, in Aurangabad earlier there were only, I mean, just giving an example, there were only three sensors. As on today, only one sensor is working in Aurangabad because of the lack of infrastructure, probably. But imagine that I can, but these recording devices, the particulate matter recording devices, have now become cheaper. So if I can put, if you go to Delhi, that has been done. So if I can put at various points of the city some sensors which will measure the particulate matter, that means PM10, PM2.5. What is PM10? Particulate matter of size less than 10 microns. This 10 microns. And then PM2.5, particulate matter of size less than 2.5 microns. So PM2.5 is more dangerous. So if you go to any air quality monitoring website, it will say major pollutant is PM10. Then another point will say major pollutant is PM2.5. Okay, so that means the fine particles are more there. What does it? How do I do that? What is the probability that what is? Suppose I don't have a sensor at a particular point, then I can do prediction. So that prediction is done by using spatial interpolation models. Now now why this is becoming much more complex? Spatial interpolation is simple, but why this is much more complicated? Because the pollution is changing with time. Pollution is changing with time, and that's the reason why these prediction and monitoring IoT models are much more complicated. So this is an application of IoT, big data, and data science to understand the dynamics of pollution. So we were talking about floods, we were talking about dams and this. We were talking about how to rescue people. They can be done using the digital elevation models, which are procured from Sentinel data and Sentinel data, LIDAR data. High resolution DM models, high resolution models are from LIDAR data, and a little bit lesser resolution DM models can be done from Sentinel data. But when you are using that data, you can recommend to the government where exactly to the build a dam. So it was said at a certain point of time that a certain particular barrage, I'm not going to name that barrage here, but a particular barrage somewhere in the eastern side of India was built at a wrong place, and Therefore, the government of that particular area will never give you the flow data before and after. They will say either you give either you take before flow data or you take after flow data, after creation data or before creation data. You can never get pre and post data of that particular site. Why? Because every such study has pointed out that the site has been selected wrongly without the use of a geographic information. And then of course there is something called human IoT. Now it's a concept which was launched by, thrown out by Dr. Arup Dasgupta, who was a former employee of the Department of Space. Dr. Arup Dasgupta talked about a human IoT. Human information can be given out. Okay, so you can collect surveys, and therefore you need to understand how you can see this. If you see this map, you are seeing that near the southeastern side of this particular country, more heart diseases are there. So you need to understand, Ki Baba, what are the food practices which are practiced there and not practiced in the north side? How they are changing, what is the diet pattern? So that particular information will help you give more medical facilities at that particular area. And this is of course the recent problem which we had for the last 2 years. And if you noted that in the beginning there were human people, there were people who were collecting the data out of their own initiative, and they created a COVID-19 website, and later the government took it over. But from the data obtained from humans, okay, they created that website, and it is completely possible to map it into a system like this. What will happen? It will monitor the spread of the disease, okay, and therefore if you do it at a local regional level, you will be able to understand how the disease is spreading, and so therefore you can actually align the vaccination strategy. So it's a kind of a big data analysis. It's a real data is coming real time there. And then this is a sentiment analysis. So there is, if you go to the internet, you will find something called a happiness index of a particular city. So you are talking about using big data and human IoT. Then you are talking about happiness analysis. So you can do sentiment analysis from data over Twitter. You can do sentiment analysis from other Facebook status messages. There are other mechanisms on which on with which how you can calculate or compute or understand the sentiments of the human being. Sentiment analysis is a typical case of machine learning. And this is machine learning applied to a geographical scenario. So here again, during the COVID pandemic, how tweets were made and how panics were there. So I am just emergency and all that. So this kind of map were generated long back. And this is how you see, after a hurricane, the power was lost in a city, and the power was restored back, and it was restored using sensors and sub-transmission analysis. And there were sensors placed on these sub-transmission towers, and as a result you were able to restore the power. So this is a smart network. So nowadays people are talking about smart grids in electrical engineering. They're talking about smart grids. So an IT guy who is working in this particular smart grid can actually create this IoT sensor network. So these are some ISRO-based applications. So you can say flood warning system. So you will need that flood warning system to warn people out of floods, and then save people from there. Then this is a map which is made created for the Assam floods, and I believe there are certain people who are from Assam here, and so you can see that disaster management and decision support can be done uh, by understanding these maps. Okay, not only so you have to procure the maps during the flood, before the flood, and after the flood. So this is how disaster management is done. So this is disaster management. So disaster management will allow you to do decision support. So it will allow you to make decisions from where supplies can be sent to the people, from where are the places where people can accumulate, so that you will give them medicines and food supplies and etc etc. So these are the locations of sewage treatment plants. A lot of places, as you can see, this is a map generated by ISRO, but you can see a lot of places they don't even have the sewage treatment plant. You can see this. So, and of course, you can talk about when you are talking about climate change. This is one global problem which is there. You're talking about climate change. So we can have big data analytics in climate change. And then, of course, since the climate change is there, what kind of mechanisms we can apply, that is a local level decision. But this is understanding climate change at a global level. This is how it is there. This is for precipitation. This is temperature. One is temperature and another is precipitation. And we were talking about mobile towers, placing mobile towers and placing forest watching towers. So this will be decision support. And this is what we call as a view shed analysis. And from one particular point, which ends of the city we can see. And therefore, I can place how many. And so therefore, you need to do three things here. One is AIML. So and then in ML, we can talk about optimization, and then we can using optimization decide what will be the minimum number of towers required to cover an entire city, or what will be the minimum number of towers required to cover an entire forest, so that I can keep a watch over the entire forest. So a digital elevation model, you will need optimization, you will need AI because the models which are available now, they are of a huge nature. So here it is. So you can see the spatial planning and decision support because of the forest. There's a lot of there are a lot of forest fires nowadays. Also in Uttarakhand, Garhwal, etc. There's a lot of forest fires and glacier. And when I'm talking about climate change monitoring, etc. So there are glacial movements which are being studied right now, actively studied right now, because climate change is a bigger problem. If I want to study earthquake analysis, so we can this is a spatial planning and decision support. An IT guy with the knowledge of image processing can actually help the government make intelligent decisions and make intelligent decisions regarding understanding where to allow to for building infrastructure. So that kind of thing can be done. So this is an interesting example for IoT and big data monitoring, big data based studies. So this is for monitoring and decision support. So one of the things that is happening nowadays is the bridges that we have, the bridges or structures that we have, dams, bridges, etc., etc. The structures that we have, they are shifting, they change they because of the age of the bridge, because of sub age of the civil infrastructure, they keep on deforming, and the deformation is very very minimal. And how do I understand this deformation is by using IoT and big data. So this is a decision support problem. When exactly do I ask the government, or do I ask the local municipality corporation or the maintenance agency to use retrofitting on that infrastructure, or to actually stop using that infrastructure? Otherwise, big accidents will happen. If I don't do that, big accidents can happen. So this is one example, and this is another example where we are talking about dams. Okay, the dams contain a huge quantity of water, and because of the movement, if the water moves a bit, the walls of the dam get a lot of pressure. So then this is required. You have to place sensors on various points of the dam, and then ultimately understand which sections of the dam are moving, and have to apply retrofitting or structural mechanism in order to prevent damage to that section of the dam. It can happen because of age. It can happen. So one of the and this is the emerging area. This is the emerging area. I'm near the end of my presentation. The emerging area is integration of the geographical information system with the BIM. Now the BIM is meant for how do you say, the small infrastructure. Like for example, if we're talking about buildings, you are talking about bridges, and this is GIS where we are talking about countries and we are talking about regions. So with the scale of data, like for example, as the scale of the data is increasing, the scale of the data is increasing in the sense that when we started remote sensing, when I started using remote sensing, the Indian satellite, the scale of the data was 23.5 meters. Today's Indian satellite is giving the scale of 1 meter. Today there we have a satellite which is actually giving me far lesser, like 50 centimeter, even lesser than 50 centimeter. So what can we do about now? That means I have not only the satellite data, also we have aerial data, we have drone data, and as a result we can retrieve 3D models. And how do I get these 3D models to interact in a GIS environment? If I go to the literature from American Society for Civil Engineers, there is a special issue on use of data science in structural engineering. There is a special issue where people are talking about BIM in application of BIM. So there is a special issue like that. So imagine that IT people and civil engineering people working together to make human life better. So this is what I see, and this is an emerging area, and therefore, let me tell you that in the job market, BIM is now highly paying. Anybody who has BIM certification, it gets paid highly. Um, so, and for people who are interested in software development for data science, machine learning, etc., there are various open frameworks. And in addition to the available existing software, there are various open software available, open frameworks available. And using these frameworks, you can design the software as you want it. Okay, there are certain basic software made, like for example Saga, Geoda. These software are already, and Grass GIS, these software are already there. They do some basic functionality. But if you want advanced, what if you want advanced, you want to, to build upon their work, their source code is also available, and so therefore you can actually have a startup where you build upon their source code and develop your own product. So thank you very much for attending this webinar. I hope this has been helpful to you. I am open to questions if you have any.
I request participants to clear up their doubts or any queries.
Yeah, the question and answers available. Yes.
Good evening, sir.
Yeah.
Sir, I'm Anuradha. I wanted to ask one question, sir.
Yeah.
How to generate DEM, sir? DEM, Digital Elevation Model.
Yes. So digital elevation models, simplest manner, simplest method. Okay. So there, if you go to the European Satellite Image Agency website, so there is a Snap toolbox. So that's the software that you need. Okay. Then you need a ESNL Sentinel account. ESA, European Space Agency Sentinel Hub account. Okay, that's the second. That's the account that you need. Next is the data. So you download the Sentinel-1 data for your particular area, whatever area you require. You draw a rectangle or you draw a square. You select your square, select the date when you want. Just download the data. That data would be uh, you can download the GRD file. I will give you the GRD file. That's called the grid file. So that grid file is about 1.8 GB. Just download that, and with that, it will be easy to generate a 10-meter resolution DEM. For Indian terrain, 10-meter resolution DEM is available. So you can download that. But suppose you don't want to get into that kind of processing. Go to the USGS Earth Explorer, open an account, USGS Earth Explorer. Open an account there and download SRTM data. SRTM is Shuttle Radar Technology Mission. SRTM, that's a ready-made DEM. Download the data. Ready-made data, the DEM is already there. Now, if you want better and higher resolution DEMs, okay, these are ready-made ones, okay. And then if you want better and higher resolution DEMs, then you have to conduct these surveys. So you have to either go to the field and use a dumpy level or a total station, conduct the survey, create the DEM. That is there. Did I clear your doubt?
Yes, sir. Yes, sir. Thank you, sir.
Any more questions? I am open to questions here. Okay, Fatima madam, if there are no more questions, you can put the meeting to an end then.
Yes. Thank you, sir. I appreciate you for your explanation regarding spatial careers in engineering and technology with simple examples, I think, which gave participants excellent coverage about spatial career opportunities and its application to IT, AIML, and data science. Thank you so much.
Okay, thank you participants for attending.
Dr. Ghosh.
Yeah. Madam.
Yes, sir. It was a very informative and excellent presentation.
Thank you,
We could get various insights of various aspects of spatial technologies. Thank you very much.
Thank you, madam.